So as we continue to add more and more properties to our, and more theorems to our bank of stuff to use for proofs, the next few sections, 2.5, 2.6, 2.7, and 2.8, are going to add a bunch of stuff. And then we just go full-blown proofs in terms of chapter 3 when we talk about congruence. So the few more properties we have to add are the addition property, the subtraction property. So again, please make sure you are writing this out. It is imperative that you write this stuff out because that is the only way that it will stick in your head. Theorem 8, Theorem 9, Theorem 10, and Theorem 11 are just long ways of writing the addition and the subtraction. You do not need to write those theorems out. You can just use the words addition and subtraction. What I would do is I would specify as segment addition or angle addition and segment subtraction and angle subtraction just to be on the safe side. But again, you do not need to write theorems 8, 9, 10, and 11 out. They are just longer ways of writing out the addition or the subtraction property. The two new properties, the first one is the reflexive property. That is something that we are going to use very often. It is sort of like the one that people read and they're like, why? That's stupid. But basically what it says is any segment or angle is congruent to itself. So angle A is congruent to angle A, and AB is congruent to AB. We use this pretty much most of the time when we get to chapter 3. It will be in the majority of the proofs that we go over, but I want to show you an example in a moment as to where it comes into play with segments. Now the transitive property, that is definitely a common one. It's going to come up again in 2.7. But the key is a transitive property is only used for congruent segments. So these are two versions of ways to use the proof. So if AB is congruent to CD and CD is congruent to EF, there is a direct connection between both of these congruent statements. So if AB is equal to CD and EF equals CD, then you know that AB has to equal EF. It's the other two items that were not in common that you said equal. And the same goes for angles. If angle A is congruent to angle B and B is congruent to C, then the direct connection is B, so A and C would have to be congruent as well. All right, first proof here. We've only got two that we have to go over in this section. So it says PQ is congruent to RS. So I'm going to note that. And that's my first statement, and my first reason is given. Now, I'm trying to prove that PR and QS are congruent to each other. In order to prove that they're congruent, you have to account for every single piece of those segments. Now, the one thing that's not accounted for is that QR, which they do have in common. So this is where the reflexive property comes in. We're going to say that QR is congruent to QR, and we can put its own little markings on there. And we're going to add that for line 2 to say that QR is congruent to QR by the reflexive property, because now that every smaller piece of those segments is accounted for, we can say that PR is congruent to QS by addition, because we're getting bigger. Because these two guys were congruent to each other, and QR, which they have in common, is congruent. So when we put them together, the sum is also going to be congruent. So that's a nice 3-line proof. For example 2, it says if AC is congruent to BD or equal to BD, so this is equal to this, is AB equal to CD? So if you look at both of those segments, they both share BC right here. So you can say that BC is congruent to itself by the reflexive property, and therefore by subtraction, AB would be congruent to CD. So yes, they both would be congruent. Now for example 3, it says HEF is supplementary to EHG, GFE is supplementary to FGH, and then we have these two sets of congruent segments, and they're marked on the picture for you. And we are trying to prove that HEF is congruent to GFE. So I copied all of my statements from my given for my first statement, and I have given. Now, if you notice, we have the same markings on both sides of the figure on top. So what I'm going to do is I'm going to add them up. So I'm going to use angle addition to then say this bigger angle is congruent to this bigger angle because they had the same markings on each of the smaller angles. And then if we go back to our two supplementary statements, we just showed in line 2 that EHG, which is right here, and FGH, which is right here, are congruent to each other. So our proof statement now accounts for the other two angles. Here's one, and here's the other, GFE and GFE. So if we look at those blue boxes, those are the two that are congruent to each other. So then the green angle and the yellow angle have to also be congruent to each other, because I'm going to write this out a little bit longer, but if two angles are supplementary to two congruent angles, then those angles are congruent. Those angles are congruent. So my abbreviations is the shorthand way of writing out this theorem. You don't want to shorthand it too much so it loses the meaning, so don't get any shorter than what I have. But if you certainly need to write the whole thing out until you understand it more clearly,